Welcome to the Explainer. Today, we're diving into what I like to call the developer's dilemma. It's that critical, behind-the-scenes battle that really determines whether your app feels smooth and responsive or just frustrating and laggy. And this isn't just about preventing crashes. It's about unlocking that truly native-level performance we're all chasing. So let's start with a core philosophy, something you've got to accept before you even think about optimizing. And it's this: guesswork is your enemy. The road to a super-fast app isn't paved with hunches. Nope, it's built on the cold, hard data you get from measuring things properly. All right, first up, let's talk about the symptoms. What the user actually feels when memory is being mismanaged. We're about to step into the ring to fight a very specific and deeply annoying enemy. To give your user a smooth 60 frames per second experience, this is your entire budget. 16.6 milliseconds. That's it. That's all the time you have to do everything. Run your code, update all the logic, and draw a completely new frame to the screen. It is an unbelievably tight deadline. And if you miss that deadline, even by a tiny fraction of a second, that whole illusion of fluid motion just shatters. Now, your user doesn't know the technical reason, right? They just know the app feels slow, it feels clunky, maybe even unprofessional. That feeling, that's what we call jank. So what actually causes this jank? Well, as you can see, there are a few culprits. Everything from using inefficient data structures to just creating way too many objects. But two of the absolute biggest offenders are memory leaks and the long garbage collection pauses they cause. In fact, for apps that run for a long time, something like 80% of freezes can be traced right back to memory leaks that force the system into these huge app-stopping cleanup cycles. And I'm willing to bet a lot of you Delphi developers out there have seen this dreaded dialogue. It's the system basically tapping you on the shoulder and saying, hey, your application isn't cleaning up after itself, and that has real consequences for performance. Okay, so to figure out how to solve this, we first have to get our heads around the two basic philosophies for handling an app's memory. It's really a story of control versus convenience. On one hand, you've got the classic Delphi model, totally manual and deterministic. You create an object, you are responsible for freeing it, usually inside a try-finally block. You know exactly when it's going to be destroyed. On the other hand, you have the world of garbage collection, like you see on Android. Here, some process runs in the background, hunting for and cleaning up unused objects. It's convenient for sure, but you have zero control over when it runs, and those cleanups can literally pause your entire application. Now, when Delphi started moving into the mobile world, it tried to find a middle ground between these two philosophies, and this led to one of the most interesting chapters in its history, what we call the ARC experiment. So, starting back in 2013 with the new mobile compilers, Delphi adopted something called automatic reference counting, or ARC. The idea was to make mobile development easier by automating memory management, kind of like how native iOS tools worked. The thinking was, hey, if the platform expects it, let's provide it. But, as you can see on the timeline, that experiment came to an end in 2020. So what even is ARC? Well, it's a pretty clever system, where the compiler basically does all the bookkeeping for you. Every time you make a reference to an object, a little counter goes up. When a reference disappears, the counter goes down. And as soon as that counter hits zero, poof, the object is automatically destroyed. In theory, this was amazing. It meant no more try-finally free blocks. But this super elegant automatic solution ran smack into a problem that was baked right into the DNA of Delphi's entire component framework. And this was the big question, right? Developers were using the new ARC compilers, they were following the new rules, but their mobile apps were still leaking memory. So what was going on? The answer comes down to something called a strong reference cycle. The classic owner/owned model in T-component is the perfect example. See, an owner component holds a reference to the components it owns, but those components often hold a reference right back to their owner. Under ARC, this created a deadlock. They were basically pointing at each other, keeping each other's reference count above zero forever. Neither one could ever be automatically destroyed. So the solution was this special command, basically designed to break the rules: dispose of. This method lets you tell the compiler, look, I don't care what the reference count says. Run this object's destructor and do it right now. It was this pragmatic escape hatch that allowed the component framework to finally break those cycles and stop the leaks. You can probably imagine having two totally different memory models, the manual way for desktop and this ARC plus disposal of system for mobile. It just got really complicated. And that led Embarcadero to make a pretty big decision to simplify things and unify the approach for all platforms. And so in 2020, with the release of Delphi 10.4 Sydney, the ARC experiment for mobile was officially over. The headache of managing ARC alongside the classic component model and needing special workarounds like dispose off just wasn't worth it. So Delphi returned to its roots, its classic, deterministic memory model, creating one single set of rules for every single platform. This table really clarifies where we are today. If you look at that post 10.4 column on the right, you'll see that now free destroys an object immediately, just like it always did on the desktop. So what about disposal of? Well, now it just calls free. It's still there for backward compatibility, but for all intents and purposes, they're identical. So, after this whole journey, where does that leave us today? It leaves us with one unified memory model and a really clear philosophy for how to build high-performance, super fluid apps on any platform. And it all comes down to a pretty simple discipline. You build fast apps with data, not with your gut. It means you measure instead of guessing. You fire up profilers to find the actual bottlenecks. And in today's unified Delphi, it means you can go back to that solid, reliable discipline of try finally free, knowing it's going to work predictably everywhere you deploy. And this quote just brilliantly nails the biggest trap in performance tuning. You see, some developers, when they run into memory errors, they'll just go into the Android manifest and flip on the large heap flag. But that doesn't fix the leaks. It just hides them in a bigger space. Even worse, a bigger heap means the garbage collector has way more work to do, which leads to even longer, more disruptive pauses, and that's what causes that dreaded jank. Don't ask for a bigger, leakier bucket. Ultimately, this entire journey, this whole explainer, it all comes down to this one question. And your answer really defines your entire approach to building professional, high-performance apps. Are you going to keep changing code based on a hunch, or are you ready to fire up a profiler and turn that vague feeling of slowness into precise, actionable data? The choice is yours.